Hey guys, we're going to be learning our second lesson today. It's about multiplying and dividing rational expressions. So first, to multiply, what you do is you factor all parts, all numerators and denominators. Then you multiply straight across or just squish the two fractions together. And then you cancel out like terms, which we talked about in the last lesson. So the first problem down here, when it's all monomials like this, if you notice that each part of this is a monomial, 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 monomial. What you want to do is you want to first multiply straight across. It's going to be a lot easier if you do that. So I'm just going to multiply the tops together. So 9 times 2k to the fourth is 18k to the fourth. And I'm going to multiply the bottoms together. 6k times 10 is 60k. All right, then I'm going to take my brain or my calculator, and I'm going to do 18 divided by 60. Math enter if you're doing your calculator, and you would get 3 over 10. Then you can reduce the k's. That k is gone, and there's left with 3 up top. So k to the third, and that's your final answer. For number 2, I do not have all monomials, so I do not want to multiply first. What I want to do is I want to squish this together, and I want to make it one big fraction. I also couldn't factor anything because the top of the first one's already GCF, the bottom's monomial, top's a monomial, and the bottom of the second one cannot be factored. So I'm going to go to the third step where I cancel out like terms. So the first thing that I can cancel is the a minus 4's are gone. Then I can look at the monomials that are left over and I can reduce those. Like this a can reduce with one of these up here. So I'm left with, I have the 3 that's right here, and then I have this a cubed that's right here. Nothing's left in the bottom, so that's my final answer. If there was nothing left on the top, you would have to put this on the bottom of a fraction and a 1 up top. But this one was on, there was nothing left on the bottom, so I didn't have to do that. All right, the next one. I can factor the top of this first one, so I can factor a 2 out, and I'm left with x minus 6. The bottom is a monomial, so is the top. X minus 6 in the bottom of the second one cannot be factored. So now I'm going to cancel. I can cancel out the x minus 6. I'm left with all monomials. So you can either reduce the monomials or you can multiply across, which we could have done that last one. So I'm going to multiply what's left over on the top. So I have a 2 and a 10 left over. So I multiply those monomials and get 20. And on the bottom, I'm left with a 5x. Now I can reduce 20 over 5x. 20 divided by 5 is 4, and that x has to stay on the bottom. And that's my final answer. The next one on the top, I can do the slide divide method. So 16 and negative 10. So what goes in 16 and negative 10 is negative 8 and negative 2. You can do that on your calculator. Bottom's a monomial, top's a monomial, x minus 8. So let me write that up there. Now I can cancel out those two things. I can also cancel out this monomial with one of these down here. So I am left with on top x minus 2, and I'm left on bottom x squared. That's my final answer. The next one, I can GCF the top. 2 comes out, x plus 6 is left over. The bottom, 3 comes out, x minus 3 is left over. The top, 2, x minus 3. And the bottom, 3x plus 6. If you're still having trouble with factoring, then you need to be asking for help during class when we're practicing. So what I can cancel out is the x plus 6's the x minus 3's. Notice they don't have to be right on top of each other to cancel as long as one is on the top of a fraction, one's on the bottom. It can cancel out. The only way you cannot cancel is if they are both on the top or both on the bottom. So I cannot cancel out those 2's on the top because they're both on the top. So I'm going to multiply them together and get 4. On the bottom, I cannot cancel out the 3's, so I multiply them together and get 9. That cannot reduce, so that's my final answer. Number 6, the top of that one has no GCF, but I'm going to do slide divide. 7 times negative 40 is negative 280. And that makes 51 on the bottom. So you put negative 280 divided by x into your y equals. You go to second graph, and you would add across until you figured out what would add to 51. It's 56 and negative 5. Now, since there's a 7 out front, I have to divide both of those by 7. 56 divided by 7 is 8, so the first one is r plus 8. This 5 divided by 7 cannot divide, so I slide the 7, so it's 7r minus 5. Okay, I'm going to now factor the bottom of this one. Negative 72 and negative 1. So that's negative 9 and 8. So r minus 9, r plus 8. The top of the second one can't be factored, but I am going to go and factor the bottom of this one. Negative 490, negative 21. I got negative 490 by multiplying these two things together. That, if you put in your calculator, would be 14 and negative 35. Since there's a 49 up front, I need to divide both of these by 49. You'd have to go to your calculator and reduce those. 14 divided by 49, that reduces to 2 over 7. So I would slide the 7 and keep the 2. So it would be 7r plus 2. 35 over 49 reduces to 5 over 7. So I would slide the 7, keep the 5. So it would be 7r minus 5. You should notice things will start to being able to cancel, like this 7r plus 2 can cancel because they're on top of each other. These can cancel because one's on top, one's on bottom. These can cancel. So I am left with nothing up top. So if I'm left with nothing up top, what I talked about before is you put a 1. What I'm left on bottom is just this r minus 9. So that's my final answer. Now let's talk about dividing. Dividing is pretty similar to multiplying. However, you need to keep first fraction the same, change the sign to multiplication, and flip the second fraction. I call it keep, change, flip. Your Algebra 1 teacher maybe called it KISS. So what you do is you're going to rewrite the first fraction exactly how it is. You're going to change it to multiplication, and you're going to flip the second fraction over. So I just flipped this over. All right, so now I'm going to factor and cancel just like I've been doing. So x squared minus 16, that's the a and b formula. A is x, b is 4. I square rooted them. A minus b, a plus b. We got some monomials, and x plus 4 can't be factored. So now I can cross those out, and I can reduce the monomials. So I can reduce the 3 and the 12, which reduces to 1 over 4, and then that x cubed. Oh, I forgot to bring the x down. The x cubed can reduce with the x. So that's gone. That leaves us with 2. And then I also have this x minus 4 left over on top. And that's my final answer for that one. All right, last one looks really scary, but it's just a division problem. This little bar right here, that's like the division sign. So what you want to do is you want to rewrite the top fraction. Change it to multiplication, and then you're going to flip the bottom fraction. Okay, now I'm going to start factoring. So 5x minus 9 can't be factored. This bottom one has a GCF. 6 goes into 42 and 48, and also they both have x squared in them. So when I take 6x squared, I'm left with 7x minus 8. I'm going to go over to the bottom of the second one. It also has a GCF. 9 goes into 45 and 81, and they both have x's. So that leaves me with 5x minus 9. The top of the second one, I can slide and divide. So make an x. 7 times negative 40 is negative 280. And 27 down bottom. I put that into my calculator, and I figure out the two numbers are 35 and negative 8. I have to divide both of those by that 7, though. 35 divided by 7 is 5, so I have x plus 5. 8 divided by 7, it doesn't reduce, so I just slide the 7, and it's 7x minus 8. So now I can start canceling things out. So this 7x minus 8 can be gone. This 5x minus 9 can be gone. All right, what I'm left with on top is this x plus 5. And on bottom, I'm left with these two monomials. So I can't cancel them because they're both on the bottom, so I'm just going to multiply them together. 6 times 9 is 54. I have x squared over here. I have an x over on the other one, so that's x cubed. And that is my final answer.